right, the first thing we're going to discuss in Chapter 4 is the compositions of solution. Chapter 4 is entitled Solution Stoichiometry. So that fun continues, only this time we're talking about solutions. And so these words come back into play. Oh, yes, they do come back into play. All right, chemical reactions are far more effective when they're done in solutions because it's easy to get the reactants to say hello to each other. So a lot of chemistry is done using solutions. All right. So in chemical reactions take place, two solutions are mixed. To perform calculations, which we are going to do, we must know two things. The nature of the reactions, which depends on the exact forms that chemicals take when they're dissolved. Here would be the exact forms. And the amount of chemicals present. By far, the biggest unit of concentration that we're going to be using is molarity. Molarity is defined as the moles of solute in liters of solution. Do not be fooled. This is solute. This is solution. Define solution for me.
It's the thing that's soluble.
Nope, it's the whole shoot max. The solute plus the solvent is a solution. The downfall of all solution chemistry is every single word that you can think of in this chapter will start with the letter S, which will kind of confuse you. All right, so molarity, which has the abbreviation large M, capital M, do not be confused, is molarity, moles of solute over liters of solution. Does it have to be in liters? Yes. All right, through the power of algebra, I have rearranged this equation to become useful for me. Moles is equal to the molarity times the volume in liters. I do recall that a mole is equal to the grams given over the molar mass. So, to figure out the grams of solute that I need, I can multiply the molarity times the volume in liters times the molar mass, and I come up with this very helpful thing. If I were you, I'd go ahead and give this a highlight because you will be using this a lot. Okay. Now, if I wrote a solution that is 1 molar, I don't know why I said that's the way you write it. You say 1 molar, contains 1 mole of solute in 1 liter of solution. So if I have a solution of, let's say sodium chloride, first of all, what would be the solute?
Water.
Nope. I'll ask for that again. What's the solute in a solution of sodium chloride? This is not a trick question. Sodium chloride is the solute, and the solvent is water. The solvent is water. Right. If I have a 3 molar solution of NaCl, that means there are 3 moles of NaCl in 1 liter of the whole solution. Okay. Problem 1. And look, the answers are right there for you. Calculate the molarity of a solution prepared by dissolving 11 grams of solid NaOH in enough water to make 1.5 liters of solution. This is on you. Go ahead and do that. Not in front of the camera. You were thinking about it. are you talking? Is that what you got? All right. Okay. Calculate the molarity of a solution prepared by dissolving 1.6 grams of gaseous HCl in enough water to make 26.8 milliliters of the solution. Tell me step 1 of this problem. Okay, the number of moles of HCl equal to 1.56 grams of HCl. So what is that? 36 grams in 1 mole. So that is now my next step. Oh, you are correct. Convert milliliters to liters by moving the decimal how many places?
3.
To the
Right. Letter.
right. That is correct. Okay. Now, here is something that bumfuzzles kids, and really, it's not even that difficult. If I ask you how many cobalt 2s are in this compound, you would tell me per mole of cobalt 2 nitrate, there are 1 mole of cobalt. And how many moles of nitrate? 2. Okay, so if I made this an aqueous solution, it would dissociate. Who recalls the term dissociate?
Just to drive off water, right?
Nope. To break apart. To break apart. Another word for dissociate is ionize, which means dissociate, which means break apart. If I were to make a solution of this ionic compound and it dissolved, it would ionize into cobalt 2 and nitrates. All right, I would have 1 cobalt ion and I would have 2 nitrates. The 1 cobalt, so half molar cobalt nitrate would be half molar in the cobalt ion, but it would be 1 molar in the nitrate ion. Are we good there? So you're conserving matter here. The iron 3-chlorate would break into 1 iron ion and three chlorates. This would be 1 molar. You would have 1 molar, 1 molar, 1 molar. So this would total 3 molar of the chlorate ion. All right, here's the definition for you. A standard solution is a solution whose concentration is known and accurate. When I order hydrochloric acid, I order a standard solution. The people who make the hydrochloric acid guarantee to me that it is accurate, and it is very concentrated too. To make a standard solution, I weigh the solute, and I put it into a volumetric flask. I add some water to dissolve it. I swirl the flask, and then I add water to the level that that I need it. Okay. Exercise 6. To analyze the alcohol content of a certain wine, a chemist needs 1 liter of an aqueous 0.2 molar potassium dichromate solution. How much solid potassium dichromate must be weighed out to make this solution? FYI, this was the stuff that was used for breathalyzers. First, I would like you to figure out any equation that you think might help us in this. Here are your choices. 1, 2, or 3. 3 would be fabulous. So the grams of solute is equal to the molarity times the volume times the molar mass. I can see that I am given readily the molarity and the volume. Calculating the molar mass, I see I have a potassium, a chromate, and an oxygen. There are 2 potassiums, 2 chromates, 7 oxygens, 39, 52, 16, bippity boppity boo. Who knows what that is?
294.
294? Thank you very much. 294 grams per mole. Times 294.
It's 200, I got 296.
I got 294 as well.
It's 39.
Mhm. So far, this is pretty easy math. Okay. When I buy these acids, this is 12 molar. I think H2SO4 is 18 molar. And nitric acid, I hazmated out of here. It was 12 molar as well. This is incredibly concentrated. When I pop the top on the HCl, it's so concentrated that the HCl gas starts coming out of solution, and this hazardous gas just kind of leaves the bottle. I'm not going to lie to you. When I open the bottle of concentrated sulfuric acid, my heart starts beating faster because I know if I drop it on myself, it's going to hurt real fast. So these are very concentrated solutions. How often am I letting you use these? Not often. You will do a lab in a couple of weeks where you're going to use 6 molar hydrochloric acid. You're going to be using those gloves that you bought, and you'll notice halfway through the lab, some of you will not be wearing gloves anymore. What happened? Well, no, it did not get itchy, so you took them off. Now, it's not going to eat through your gloves, but it certainly will discolor you. Okay. All right. I am going to dilute the acid for you. Okay. Now, before we start talking about how to make dilutions, we need to get some...
acid to water.
Just like your otter. Very good. Acid to water. Okay, we need to define concentrated and diluted. All right, not strong and weak, concentrated and diluted. Concentrated is defined as a solution that has lots of solute in it for a given amount of solvent. A dilute solution has a little amount of solute for a given amount of solvent. Now, you cannot concentrate a solution. I can't take my 12 molar stock solution and make it 15 molar by taking out some of the solvent. That doesn't work for me. I can only go the other way. I can take my 12 molar and make it 6 molar, make it 1 molar. Sometimes, actually, you used NaOH in the last lab that you did. It was 0.1 molar. So you're using very dilute solutions. Now, this is one of the most important equations a chemist can use. M1V1 equals M2V2. If you'll notice from one of the molarity is moles over liters. Moles is molarity times volume, MV. Okay. So what you're really saying is before and after. Okay. Now this is kind of hard to wrap your head around. The molarity is the moles per liter of solution. The number of moles doesn't change before or after the dilution. The only thing that changes is the volume. Okay, so this is the molarity of your concentrated solution and the volume that you need to use to make your diluted molarity at the volume you want. So this would be the volume of dilute solution you would like, and this volume is the volume of the concentrated solution you need to make the dilute. You need to make dilute.
What does that say?
The volume of the concentrated solution that you need to make the dilute solution. All right. What volume of 16 molar sulfuric acid, the formula of which is, right there, H2SO4, must be used to prepare 1.5 liters of 0.10 molar H2SO4. Okay, so M1V1 equals M2V2. M1 is 16 molar. V1 is the volume of concentrated solution that we need to make the dilute. We don't know yet. M2 is the dilute solution concentration, 0.1 molar. V2 is the desired amount of dilute solution, 1.5 liters. Substituting in, 16x is equal to 0.1 times 1.5. To make 1.5 liters of the dilute solution, you must use 9.4 mLs of the concentrated solution. Well, that seems easy enough.